In this video, we're going to go over a couple more examples dealing with velocity and displacement. This problem is number 10 in your textbook at the end of chapter 2, and you'll see that I've modified it slightly so that it fits our Cincinnati idea. It says you and your best friend are meeting at Kings Island for a day of fun. You both leave from your house 10 miles from the park. You drive in separate cars. You're a law-abiding citizen, so you drive the speed limit of 55 miles per hour, but your friend is a speed demon traveling at 70 miles per hour the whole way. How long does your friend wait for you? Again, we're going to follow the gummies method, starting out by writing out what we know, picking out information out of this word problem. The first number I see is that it's 10 miles from the park. That's going to be a displacement value. So I'll write that as delta x equals 10 miles. Next number I see is this 55 miles per hour. And it says that that's your speed. So I'm going to call that V average for you, 55 miles per hour. And your friend is going at 70 miles per hour. We'll call that V average for friend. I don't have anything about direction here, which is okay. I'm just not going to put those vector symbols on top of my variables. My units all match here because MPH is miles per hour and I have something in miles. It's okay that they're not SI units. As long as our units match, we're good. So we'll move on to the U portion, the unknown. It says, how long does your friend wait for you? That means I'm looking for time. The M's, model and method. I need to look for how much time it takes each of us and then subtract. So I'm going to find out the time for you and the time for your friend. And then I'll subtract those two, and that gives me my answer that I'm looking for in this problem. To find this, I'm going to use the equation V average equals the displacement divided by the time, which means that time is displacement divided by the average velocity, divided by that magnitude of that average velocity there. I'm now on the I portion, the implementation, where I get to start plugging some numbers in. I don't really care about the rest of the problem. I've got everything I need right here. So the time for you is your displacement, 10 miles, divided by your speed, 55 miles per hour. The time for you comes out to be 0.18 hours. For your friend, 10 miles, it's the same displacement, but this time they're going 70 miles per hour. 10 divided by 70 gives me 0.14 hours. So then to find the time difference, to find how long the friend is waiting for you, we'll take the difference between these two times, which is 0.04 hours. We're finished with the implementation step, which means we get to the evaluate your solution step. I don't know about the rest of you, but I have no concept of how long 0.04 hours is. So I'm going to convert that into a unit that I'm more familiar with, which would be minutes. To do that, I just multiply by 60, and I find that 0.04 hours is 2.4 minutes. Okay, is that a reasonable answer? Yes. And it's actually very interesting finding out that your friend, who's going a whole 15 miles per hour over the speed limit, is only getting there 2 minutes faster than you are. Is speeding really worth the risk? Well, this problem tells me that it's not. Moving on to the next problem. This one's number 5 in your textbook. It says two boats start together. They race across a 60-kilometer wide lake and then back. Boat A goes across at 60 kilometers per hour and returns at that same speed. Boat B goes across at 30 kilometers per hour in its crew, realizing how far behind it is getting, returns at 90 kilometers per hour. We're pretending like it takes 0 time for it to turn around, and that the boat that completes the round trip first wins. Okay, starting off by writing out what we're given. We have 2 boats this time. I'm going to make 2 different lists of my givens. So boat A and boat B. Okay. Each boat also kind of has 2 displacements, one there and one back. So on the way there, the displacement is 60 kilometers, and the average velocity for boat A is 60 kilometers per hour. For boat B, the displacement on the way there is 60 kilometers, and the average velocity is 30 kilometers per hour. Then we go with on the way back. The displacement is the same on the way back, 60 kilometers. But the speeds are, well, the speed is the same for boat A, because it tells us that it does both trips in the same speed. But boat B really picks up its speed. It's going 90 kilometers per hour on the way back. If I had treated there and back all as one portion, if I didn't split it up like I did here, I'd have a displacement of 0, because the initial and final point would be in the same spot. So it's important to split them up like I have. All our units match, so we're allowed to move on to the U, or the unknown. Looking at part A, it's asking which boat wins and by how much time. Okay, which boat wins and by how much time? Well, to find out which boat wins, we have to find time. So our unknown is time. We're going to have to find time 4 separate times. For each boat on the way there, and for each boat on the way back. I'm getting into that model and method here. I'm going to go ahead and label these part 1, part 2, part 3, and part 4, just so we can follow along with what we're doing easier. For all of the parts, I'm going to use the equation V average equals delta x over delta t. Solving for t, this gives me delta x over V average. Okay, so for part 1, I'll have that time is delta x, or 60 kilometers, divided by V, or 60 kilometers per hour. That gives me 1 hour. Part 2 is the exact same math, so we know that that's also going to take 1 hour. For part 3, delta t equals 60 kilometers divided by 30 kilometers per hour. That takes 2 hours. Well, okay, it's pretty obvious already that boat A wins, because it took 2 hours for boat B just to get to one end. But I'm going to need this number anyway, so I might as well calculate how much time it took them to get back. 60 kilometers divided by 90 kilometers per hour. That gives me 0.67 hours. So then the total time for A is 2 hours. The total time for B is 2.67 hours. So A wins, but the problem also asks by how much. To find out how much, I just subtract these two numbers. So that A wins by 0.67 hours, which is the same thing as 40 minutes. That's a logical amount of time for a boat race to happen, especially when they're going 60 kilometers. So I boxed my answer. Moving on to part B, it says, what is the average velocity of the winning boat? Well, we're talking about average velocity for the whole trip. This is a tricky problem. Think about it. I already mentioned in this video what the average or what the displacement was for the whole trip. You remember what I said? If you're thinking that I said that the displacement was 0, you are correct. Average velocity is displacement divided by time. So the average velocity for boat A is 0 because its displacement is 0. Now, if this said average speed, things would be different because we don't pay attention to displacement when we're doing speed. Speed would be distance over time. Clearly, this is different. Notice also that this average velocity, if I had just averaged its velocity over its total trip, I'd be saying 60 kilometers per hour. Clearly, that's not correct either. You have to pay attention to the actual displacement to get your answer to part B. Hopefully this video helps clearing up any questions you may have had with these two problems. But if you have any further questions, feel free to email me or bring those questions to class with you.